Today we'll talk about z-scores. A z-score is the number of standard deviations either above or below the mean a data point in a normal distribution is located. As an example, in a normally distributed sample with a mean of 4 and a standard deviation of 6, the value 10 is one standard deviation above the mean, since 4 plus 6 is 10. We will refer to the one standard deviation above the mean as a z-score of 1. We can write this as z sub 10 is equal to 1. In the same scenario, where our average is 4 and our standard deviation is 6, the value negative 2 is one standard deviation below the mean, since 4 minus 6 is negative 2. We will refer to one standard deviation below the mean as a z-score of negative 1. We can write z sub negative 2 is negative 1. Z-score equation. In a normally distributed sample with a mean x bar and a standard deviation s, the z-score of a data element x is z equals x minus x bar over s. This formula will help us turn a normal distribution into a standard normal distribution. We'll be able to tell how many standard deviations we've moved from the mean to find our data point. Let's find the z-score for a few data elements. Given x bar is 5 and the standard deviation s is 4, let's find the z-score for each of the data points. Let's start with x is equal to 11. To find our z-score, we take the 11, we subtract the mean of 5, and then we divide by 4. 11 minus 5 gives us 6. 6 over 4 is 1.5. We can write this as z sub 11 is equal to 1.5. Let's try it again with the data element x is negative 8. Again, we take the data point negative 8, subtract the mean of 5, and then divide by the standard deviation 4. We get negative 13 over 4, which is negative 3.25. If we wanted a notation, we would use z sub negative 8 is equal to negative 3.25. A set of data is normally distributed with a mean of 7 and a standard deviation of 9. Let's convert 11 to a z-score. We'll have 11 minus 7 over 9. 11 minus 7 gives us 4. 4 over 9 is 0.44. It's really important that you pay attention that we're always using the data element first, and then we subtract the mean, and then we divide by the standard deviation. In this particular case, 4 over 9 is a repeating decimal of 4, so we just round it to 2 decimal places. Suppose the length of a movie is normally distributed with a mean of 96.5 minutes with a standard deviation of 10.8 minutes. Let's find the z-score for a movie that is 75 minutes long. At this point, I'd really like you to stop the video, do the calculation, find the z-score, then rejoin the video to make sure that you're getting this correct. Here's what we should have for our calculation. Our data point is 75. We subtract the mean 96.5, and then we'll divide by our standard deviation of 10.8. We get negative 1.99. Let's try it again. Suppose the length of movies is normally distributed with a mean of 96.5 minutes and a standard deviation of 10.8 minutes, just like the last one, but this time we want to find the z-score for a movie that is 105 minutes long. Once again, we'll take our data element, 105, subtract the mean, 96.5, and then divide by 10.8. We'll get 0.79. The amount of rain a city receives in June is normally distributed with a mean of 8.4 inches and a standard deviation of 1.4 inches. Let's use the 68, 95, 99.7 rule to determine the percent corresponding to the city getting over 9.8 inches of rain. Let's start off by finding the z-score for the data element. Our z-score is 9.8 minus 8.4 over 1.4, which corresponds to the number 1. Let's look at the chart. So here the chart, we have our 68, our 95, our 99.7. A z-score equal to 1 is right here. What we're looking for is having more than 9 inches of rain. So from this 1, more would be everything to the right. So I can see there are two numbers. They are 13.5 and 2.35%. Adding 13.5 and 2.35% says there's a 15.85% chance that we're going to get more than 9.8 inches of rain. Let's try that again. A test is normally distributed with a mean of 82 and a standard deviation of 8. What percent of students would score between 74 and 98? Again, we're going to use the 68, 95, 99.7 rule. This time we have two numbers we need to convert to z-scores. We have both 74 and 98. So converting those two numbers to z-scores, we have 74 minus 82 divided by 8, which gives us a z-score of -1. We also have 98 minus 82 over 8, which is a z-score of 2. So let's look at those two numbers on our graph. -1 is on the left, and then +2, which we go 1 and then 2, is here on the right. So I have a 34%, a 34%, and a 13.5% represents what part of the graph should be between these two numbers. So adding 34, 34, and 13.5 says we have a total of 81.5% of the students that should score within this range.